Hey friends, I'm Scott Hanselman. This is, I guess, another episode of things they didn't teach you in school, computer things that they didn't teach you in school. In this one, we're going to talk about containers. Now, this is not a Docker 101 class. It's not everything you need to know about Docker. It's more of a Docker, I don't really understand what containers are. Like, I use them every day and I kind of guess why they make things better, but I don't fundamentally understand what's happening. So, as with all my videos, why don't we try to explain it in one take with real code and real examples, and I'll do my very best to get you to understand containers. So what? That'll probably be the thumbnail for the video. The YouTubers, they do thumbnails. That'll be my thumbnail. Docker, so what? So let's do this. As we always do, let's go out of the command line. Now, for context, I'm using Windows 10. I'm using Docker that I've installed on this machine, and I'm using WSL2, the Windows subsystem for Linux. If you have a Mac or a Linux machine, install Docker and do the same. If you have Windows, install WSL2 and Docker. I may do a more detailed video on that, but I believe I've done a couple of videos to explain that, as well as a number of blog posts. So let's just forget about the details of whatever operating system you're running. Let's get back to the basics. I'm in my terminal, and I open up my directory, and I've got some stuff here. Now, I wrote earlier, just a couple minutes ago, this Hello World C application. It's got standard I/O, and it's got a main, and it says Hello World, and then it leaves. It prints something out, presumably to the console. And then I went and I ran GCC, which compiles that C code, and I put in static linking to make sure that I got everything that I needed in my little Hello World. And now I have here this Hello World. You see that that's green. And I can go here and let's look at that. You see that it's marked as executable. That's what that X means, that folks can run it. It's got a little star by it, and then got some color there. And I'll say, hey, Hello World. This is on my Linux machine. Now, again, I'm using WSL on Windows, but this is Linux, real Linux kernel. So I ran that and it works. I can run it again. I can close my Linux machine. I can shut it down entirely, and I can open it up again, pretend that I've rebooted. Okay, and I'll go back to that folder. And that file is still there. This is a persistent installation of Linux. Those files stick around. They're not going anywhere. They're always there because I've set them up on the disk. Now, you can mess up a computer. You've probably done that before. If I made a mistake, if I deleted that, if I renamed it, if I put it in the wrong location, if I did some installation and I messed up my machine, that could be really frustrating. Sometimes you'll go to work at a company and they'll give you a document and they'll say, here's the instructions on how to set up your machine. Even more, they might say, here are the instructions for how you set up the server. Install Nginx, install Apache, install Python, install PHP, put .NET here. You set that whole thing up. And that's annoying because if you get it wrong, then you're going to have configuration issues. And when you're dealing with 1, 2, 8, 64, 256 computers, if one of them is wrong, then you have configuration issues. So then people came up with the idea of virtual machines, machines inside of machines, where you would actually lie to your machine. The guest lives in the host and it has everything set up for it, and virtual machines could be paused and stopped and started, and that was really cool. But virtual machines are kind of heavy because, well, let's look at a diagram. Actually, one of our friends in the comments suggested that rather than using Paintbrush, I consider using this draw.io. So I spent a few minutes and I familiarized myself with draw.io. So let's say you have your hardware. Let's see if this is going to work out nicely for us. We'll try draw.io to make my boxes instead of what I like to use, which is Paintbrush, or maybe Windows Whiteboard, Microsoft Whiteboard. And then you got your host operating systems. You got your hardware, you got your host operating system. And then when you're doing things with a virtual machine, let's say you're running a couple of virtual machines, right? We'll say this is VM1, and you need an OS. You need the whole operating system of that. VM2, the OS. And that might be a lot of space. That might be, I don't know, 20 gigs could be. However big the operating system is, if it's Windows or Linux or Ubuntu, you need a bunch of stuff. And then here's the fun part. You take your application, let's say your application is Hello World, and you put that on top. And then you have another application over in here. Maybe this is your website. In order to call Hello World, I'm going to go and call some system calls, some calls that are available in the operating system. They're probably available in this host operating system. It knows how to do things like console.writeline, but instead I'm going to have this whole operating system that I'm carrying around with me that might be 10 gigs. It's certainly not small. Maybe if it's a small Linux, it could be a couple of 100 megs, but it's a size and it's duplicative, meaning there's duplication. I have my little Hello World app, my virtual machine, and then between these virtual machines and this host operating system, we have a thing that's called a hypervisor. Now, hypervisor is the thing that does all of the lying. If you've ever heard of VMware or Hyper-V or VirtualBox, they're all hypervisors. This is Hello World. There's a virtual machine with its own operating system that's being managed by the hypervisor that lives inside of a host that sits on top of hardware. That's kind of a lot. Remembering that the host operating system probably has the things we need. If you were to make a list of the system calls that you would want to run most, let's say, web applications, you'd need opening up sockets and writing out to consoles and writing to files and doing stuff like threading. You'd have a list of some system calls. What if you could get rid of the hypervisor, get rid of the virtual machines, bring these closer, but you don't really want them to be running just like regular apps. Remember, I can mess up my host operating system. I don't want them that close. So I'm going to need a little bit of help here. So what I'm going to do is I'm going to put Docker, specifically the Docker daemon. I always forget how to spell daemon. Right there. And then these apps are going to need a little bit of help. They're going to need some extra stuff because every app is different. So they're going to carry those things along with them. They're going to carry their binaries and their libraries, just the ones that they need. This is super important. We want these applications. I want Hello World to have the least. I want Hello World to have nothing. If there's a library I don't need or a function I don't need to call, then I won't even include it. It won't even be involved. And then the little tiny Docker daemon, it's very thin. It's a nothing little thing here. We'll broker these calls, this relationship. So these are much lighter, much smaller. Now with a virtual machine, usually someone hands you a virtual hard drive. Here is the hard drive of this machine. Here's a giant file, as much as they'd said, here's a disk drive that I'm going to hand you, except it's virtual. Okay? So how do we describe these things so I can hand you something smaller? All right, let's go and talk about that. Let's say I'm in a folder here called containers. All right, and what I'm going to do is we'll try to show how this works in the absolute nothing example. Let's use Visual Studio Code to do our editing, and I'm going to open up a Docker file. And in this Docker file, I'm going to have nothing. And what I'm going to do is I'm going to say, from scratch. We're going to start from scratch, literally like when you bake a cake, start from scratch. Now I want to run my little Hello World application. Now remember, a Hello World application in C can be quite small, but in this case I did that static. Remember I said dash static. I brought the libraries I wanted. So this file's a little bit bigger than it needs to be. It's about a meg. Probably could have made it smaller, but bear with me. I have a little tiny Linux Hello World file here. And I'm going to say, from scratch, let's go and copy Hello World into the root of our new little container, not a virtual machine. And then we're going to run, when we start up our container, we're going to go and run Hello World. Now it looks like a batch file or shell script, but this is Docker language. It's something on the left and something on the right. These are kind of verbs, and these are the nouns. So from scratch, copy my file into this new thing that doesn't exist yet. So look at my folder, all we have is a Docker file, and we have hello world. All right, let's clear that out. And let's go and say Docker build. I'm going to say Docker build. I'm going to tag it, give it a name. I'm going to build a container that's called my test, and I could put a version at the end of it. We'll just call this one the latest. This is really, really important. Notice that there were 3 lines in that Docker file. So there's 3 layers here. There's 3 things that are happening. There's moments where something happens, and each one gets a little name. So they all got little numbers. So there's a Docker image that just got built, and I can go and type Docker images, and I can see there it was just 30 seconds ago. Look how tiny it is. It's just about the same size as that hello world binary, because that hello world binary is inside there. Now I said from scratch. I didn't say from Ubuntu or from Linux or whatever. I just said from scratch. That just assumes the absolute base Linux machine, POSIX, what they call POSIX, or the base nothing, just the minimum amount. But if you go back here, remember that we said we have a host operating system. So I really have basically nothing in here. A megabyte. Let's make that really small. Just the least. And the Docker daemon's going to manage that. So now I could say Docker run. All right. And we're going to go and we called it my test. I think we call it latest. All right. And it says hello. Now this is really important. It comes and it goes. Starts up and then it ends. That's really important because Docker containers, or any kind of container, are ephemeral. They start up and then stop. So what does that mean? Well, there's another tiny little container I used from scratch. There's another tiny container in the world, and that container is called busybox. Busybox is this tiny little base image. These are all base images that you can start from. You can pick all kinds of base images. I'll pick some different ones, but busybox is the smallest possible Unix thing that you could ever start with. Okay, what we're going to do is we're going to change our Docker container, and instead of building from scratch, I'm going to say from busybox. We'll get rid of hello world for a second. All I'm saying is from busybox. It's again just the Unix utilities that you need. It's really nothing. And let's go and do this. We'll build it again. It's like compiling some source code. Now look, I don't know if you saw that, but it said pulling. It didn't have it locally, and it pulled it down, and it said I'm going to go and get an image for busybox, and I'm going to say Docker images. Now I have the one that we built earlier. I'm sorry. Well, oh, I deleted it, so that's a good point. Notice here, remember I made my test before? I should have given it another version number. Now we've got busybox latest, only a megabyte. I didn't put hello world there. My hello world one is just kind of orphaned at this point. That's that intermediate one. Let's go and do this. Let's go and say run. All right, look at that. I'm at a different prompt. What's going on here? Where are we? What can we do? Can't really do anything. The reason I can't is because I didn't tell it to be interactive. I want it to be interactive and let me see the outputs. I'm going to add that I. Now I can type. I'm in a little busybox. I've got another little Linux right here. So let's make a file. Here is my new file. There it is. I see that. I could make a hello world.txt. So I've just put, just put 2 files. Oops. There we go. There we go. I've got 2 files here in my busybox. So I'll exit. Now we're back out where we were before. Let's run busybox again and go see if our stuff is in there. It's not. Really important. When the Docker container stopped, it's gone. Gone forever. Very important. So I'll need to have those files be stored somewhere else, because this is a perfect machine set up exactly as I described it. How is it set up? It's set up exactly as I described it in my Docker file. Now, I could have said, let's go ahead and exit. Docker run busybox latest here. I'm going to pull that down from the on high. You notice it didn't have to because it was already local. Remember, we have Docker images. So I've got the latest one. It looks like no one's even touched it for 3 weeks. But I wanted to build on top of it. So now I could go in here and we could say our hello world this way, because busybox has a little bit more than Scratch does. I want to say, hey, echo. So we'll go back, do a build. I don't need to run it interactively. Oops. I want to run my test, the latest, and it should say, welcome to Docker. Oh, it's mad at me because of that. I don't even need that. There you go. Cool. So this allows me to run a thing without messing up my local system at all. I could do something a little bit more complicated. Why don't we do this? Rather than building from scratch or building from busybox, we could build from, let's say, Ubuntu, which is kind of a little bit more legit, a little bit bigger, a little bit more functionality. And then what if we go and we copy this hello world over there? Would that work? We're going to copy it from our local machine inside the container that we built and then run it. Go back. We'll build it. And look at this. Watch. Look at that. Layers. So that means that the Ubuntu base Dockerfile has other layers before it, and it's the layering that makes things so interesting. You start from a base image. You say, you know, I want my application to start from Ubuntu, and then I'll add something, and I'll add something, and I'll add something, and each layer gets cached. It gets cached, so it's local and it runs fast. So these binaries and libs, and then build on other images that build on other images that build on other images. And once they're cached locally, they don't have to get built every time you run them. They're super fast. You completely design these from scratch the way that you want. And now let's go and run this one, our Ubuntu one. Should say hello. The only difference here was that we started with Ubuntu. Now I could say Docker run, and I'm going to say remove it when you're done, Ubuntu latest. And now look at that, a little bit more than I had when we were looking at busybox, because I've got more stuff in there, more Ubuntu stuff. Now, if I wanted to do something like this, like a website, I could find a base image that included that. And there is one that's called Nginx. Now, this is where things get interesting. If you followed with me so far, remember we talk about layering. So here's their actual Nginx web server Docker file. From the Debian base, using the Buster Slim version, I called mine latest. They're going to go and they added a little label so we know who does it, and they put some environment variables, and they're going to look at this. They're going to start setting it up. They're saying that this image is just one slice of what we need. After we get that image, we're going to update some things, we're going to add some users, we're going to set up our server, get some Nginx packages, do all this stuff. All of this could run on my computer, and I can do the build. Or we could just go and get that image from the Docker hub, the Docker repository. And that Docker repository is a place where all of these Docker files are stored. So if we go up here to Docker hub, all these images are up here for me to pull down. Some are big, some are small, some are base images for you to start from. Let's just see if we can say hello world, not with text now, but instead with a web server. So what we're going to do is is we're going to say Docker run, remove it when you're done. We'll name it Docker Nginx. You can name it whatever we want. And then this is going to be interesting. We're going to say, I want to set up a port. I'm going to say like, well, port 81 on my computer is going to be port 80 inside the container, because the container is a little operating system of its own. So it's got a little port sticking out. Oops, that's not a very good port. That's going to be port 81. We're going to map that port to port 80 on my host operating system, so that I can go and connect maybe a web browser. Maybe this will be my web browser. So this here is port 80. This here will be localhost 81 on my browser. Okay? So let's go back out to our command line, and then we'll just name it Nginx as well. Now watch it as it pulls down. This is important. See how many layers are. Unable to find image. Oops. Now look at this. I got a little error. Great thing. This is a really important deal. Sometimes when you make a mistake and you're beginning your career, you can get overwhelmed. You can stare at it for a while. But if you actually read the error message, you can see that I've actually forgotten to put in a hyphen here. That hyphen is a switch, in this case for port. So they were telling me what was wrong there. Okay, unable to find image. Now look, watch. 1, 2, 3, 4, 5 layers, 30 megs, 30 megs. Look how fast that was. Okay, cool. So something's happening. This was the pulling of the images. Now it's actually running. Let's go over to our browser. Let's go to localhost 81. Look at that. If you see this page, the Nginx web server is working. Let me put that over here on the right, and I'll put that on the left. I'm going to hit Control-C. I'll hit refresh. Still running. We can run Docker PS. We can see that we've got some containers that are running. This one that we just made called Nginx is running. Remember that mapping I mentioned? We moved port 81 on the outside, points to port 80 on the inside. I've got this nice little thing. Now I named mine. I named it Docker Nginx. If you don't name it, you'll just get a cool name of an adjective plus a scientist. Now if I say Docker stop, I can give it a container ID. This is the unique ID of my container. I'll just pick the first couple of numbers because that's unique enough. There's no other containers that are named 1C. And then let's go and hit refresh. See how it's not working? Gone. That's cached. See? Oh, can't reach the page. Docker PS. We've got busybox kind of sitting around still running. Probably need to get rid of that. And we've got another one that we made that's running as well. We'll want to shut that down as well. Now, if I type Docker images, these are the list of the little images. Notice that none of these are really large, and all the layers in between, some are named, some are not. busybox, Nginx, Ubuntu, the one that I built, my own. So why is this interesting? Well, here's my podcast. I have a podcast. You can check it out. It's at hanselminutes.com. I like it very much. You should check it out. I got lots of cool and interesting fresh faces, including people that have worked at Docker. This website is run by me, and when I build it, I've got my .NET code here, I've got my tests, and I've got a Docker file. So let's look at that Docker file. Let's open that up in VS Code. This is a real world kind of production Docker file here. I see the from using the Microsoft Container Registry, and I pull out of image that Microsoft makes of .NET, give it a name, decide that we're going to work in a certain folder, and I start copying my code into it. This is cool because you can use Docker files to go and compile your code as well. This means that I don't even need to have .NET or Go or Rust or whatever I have on my local machine. In this case here, all the code is going to compile and run inside that file. And then we actually compile and build in our Docker file. Each layer gets cached. I run my tests. I ultimately publish a release version of my website. Then I get another Docker file, publish the version of my website that I'm going to put into production, and then launch it. All in one call. Now I made a little script to do that, but I'll show you what it is. It's not really rocket surgery. Remember that Docker build command that we did before? Docker build, and then we tag it. Let's try typing that without running the script. All right. Now this will be slow one time because I cleared out my cache and I wanted you to see the layers. The .NET SDK containers brings down the images in layers, pulls them down, extracts them. Now once it's done that once, it'll be fast. That's what's so nice about this. Didn't bring down 5 gig or 30 gig operating system. Didn't bring down too much, just enough to do the job. And again, every step gets a name and a layer. And then if it notices it doesn't need to do it again, like for example, this step 23 here is quite a slow step. Say it took 11 seconds. I don't want to do that every time. So the next time I run this, if it doesn't detect that that layer needed to change, the layer will get reused. And that means that Docker files can get built really quickly, and then they also start up very, very fast because all those images are pre-built. We've just built my application. Now we're actually going to run our unit tests in Docker. Now what's great about containers is that I can just hand this to you. I could give you the Docker file or my image and you could just do it. If I said to you, hey, go and run Docker, run Nginx, hit enter, you try this line on your system, it'll work because you'll have Docker installed. It will pull this down. You'll get the exact same thing, and then you'll see an Nginx web server startup. Okay, mine is just built. It called itself podcast latest. I'll say Docker images. You can see podcast is right here. My whole podcast site is only 256 megs. Then I can go and run it. Let's look at what that looks like. Very similar to the way we ran Nginx before. Okay, let's go and run that. So we'll run that container. See how quickly that starts up? All right. Let's go and hit localhost. Look at that. There is the local version of my podcast running right there. Let's stop it. Run it again. See how fast that starts? Stop it. Let's build it again. See how fast that went? Because nothing changed. Things get cached. Each layer gets cached. So if we go back here, my website layer had 23 different layers. It had each individual step, each individual moment. Some of them might be individual Docker files. Some might be steps within a Docker file. There's a whole rich ecosystem for you to build on. It's much lighter weight, much easier to work with. Now again, that the data is erased. The file system that gets changed, if anything gets changed, it disappears. When the Docker file stops running, there's nothing happening in there at all. I want to remind you, if we go and run a Docker file, and look in here, maybe I'll make a new file. You can see it. I leave, I come back, it's gone. It's like pulling the plug and plugging it back in. It wakes up and it's a fresh baby, just born, doesn't know what's going on. So you can mount volumes, you can have external storage, or in the case of my podcast, I use an external database. So it's okay that my application starts up and it doesn't know anything. That is the power of containers. That's the answer, I think, in one take. It looks like it took me about 30 minutes. Sorry, that was a little long. Of containers, so what? I know I was moving fast, but this should give you the fuel that you need to go and learn about Docker, to learn about containers, and why they're interesting, why they're fun, and why they're useful. Fundamentally, they are a useful thing, and I think the future of how we're going to build, deliver, ship, and run software. And another time, perhaps we'll talk about Kubernetes. Kubernetes, or what are called container orchestrators, because one container is just one musician in an orchestra, and you need a conductor to orchestrate all of them together. So maybe we'll do another one about that. Again, if you find these videos useful, please leave a comment, smash that bell, subscribe, and honestly, the best thing that you can do to help me out is let me know what you think I should talk about next, and whether or not you find these useful. Certainly tell a friend. That would be great if they came over and subscribed as well. Thank you very much. This has been computer stuff that they didn't teach you in school.